In this video I will talk about what blueprints are, some pitfalls you need to be aware of, and show you how you can get started using them through some simple examples in Unreal Engine 5. Getting started with Unreal can be very intimidating, but I specifically designed this video so that anybody can follow along, even if they've never done any programming and never touched Unreal Engine before. Blueprints are the visual scripting language of Unreal Engine, and they allow you to implement game logic and systems without having to write C++ code. Visual scripting is not something that is exclusive to Unreal Engine, and there are many other game development tools that have their own visual scripting implementation. However, Unreal Engine has been doing this for a long time and made their system really robust over the years. Just look at how old this website is and you'll know what I mean. A benefit of blueprints you'll often hear people talk about is that it makes it easy for designers to make small changes for playtesting and balance adjustments without having to rely on a programmer. But even if you are a programmer, there are many benefits to using blueprints over C++. With C++ you have to spend a lot of your time looking through documentation and waiting for your code to compile, which is why you can work so much faster with blueprints. But on the flip side, C++ can be compiled down to a format that is easier for a machine to understand, while blueprints will have to be interpreted through a virtual machine. This means that C++ is more performant and will allow your games to run at a higher frame rate. But in many cases this isn't really an issue. I've even made a commercial VR game using only blueprints that runs at a smooth frame rate. So this isn't anything you should worry about early on. As you become more experienced over the years, you might want to use blueprints and C++ in combination for the best effect. I encourage you to follow along with this exercise, so make sure that you have Epic Games Launcher and Unreal Engine 5 installed. Click on Launch to open the project window for Unreal Engine 5. Select Games and Third Person. Make sure that the project defaults are set to Blueprint and that starter content is enabled. After loading is finished, you should see this editor screen. When you press play, you already have a character that can move around and jump, since we picked the third person template. This character is a blueprint class that is provided by Unreal Engine. First, we need to talk about the content drawer a little bit. You can press this area on the lower bar to open the content drawer. Alternatively, you can also open it up by pressing Ctrl and spacebar. The content folder in the drawer basically mimics the files that are saved on your disk for this project, and this is the folder we'll mostly work with. We now want to create a folder for our blueprints, so right click and add a new folder, then double click to open it up. We now want to create our first custom blueprint. Right click in the drawer and select Blueprint Class. You will see a window pop up that asks you to pick a parent class. A parent and child hierarchy is not something that is unique to Unreal, but is actually a core concept of object-oriented programming. There is a wide variety of classes available inside of Unreal Engine that allow us to easily create our own functionality on top of them. But most of the time you will either use an actor, character, or game mode. The actor is the most basic class that can be placed in the game world and is what we will use for our first blueprint. When naming a blueprint, a popular convention is to prepend the name with BP_ to keep things organized. So let's call this BP_test. Double click to open up the blueprint. Then grab the tab to attach it to the main editor window to make it bigger. The view that is shown in the middle by default is the viewport. This will show you all the visible parts of your blueprint. An actor blueprint doesn't necessarily have any visible parts, which is currently the case. We can go to the Components tab on the top left and click Add to add a sphere component, which is a type of static mesh. We now want to see what our blueprint looks like in the game world, so let's save and compile. Go back to the Third Person Map tab and open up the content drawer. You can see that the sphere is now shown in the thumbnail of our blueprint. Simply grab it and drag it into the game world to create an instance of it. While it is selected, you should see a gizmo with 3 arrows. We want to move the sphere up in the air a little bit, so select the blue arrow with your mouse and drag it upwards. When you start the game now and walk up to your blueprint, you can see that the static mesh, which is contained in it, by default has the proper collision setup and doesn't allow our player to just walk through it, but it is floating in the air. Let's go back to our blueprint and try to set this mesh to be a bit smaller and affected by physics. Make sure that the sphere is selected in our components menu on the left. Now we can see the properties of the sphere in the details panel on the right and can also freely edit them. First, set the scale to 0.5 for X, Y and Z. You can do this one by one, but you can also click this lock item and do it for all of them at once. Let's search for simulate physics and set this to true. Again, make sure to save and compile. Go back to the third person map and click play. You can see that our changes have been applied to the blueprint instance in the game world. Finally, it's time to talk about the event graph. This is the most important part when talking about blueprints, and you will spend most of your time working with it. You can access it through the tab at the top, or by double-clicking on event graph on the left side. As you can see, there are already 3 nodes prepared for us that are frequently used. However, since nothing is connected, they are grayed out and inactive. If you don't need a node, you can delete it by right-clicking and selecting delete. You can also delete one or more nodes by selecting them and pressing delete on your keyboard. To undo any changes you did, you can press Ctrl+Z like you can in most programs nowadays. To create new nodes, just right-click somewhere on the event graph to bring up the context menu. This gives you access to the absolutely huge library of functions that are available in this blueprint. We want to bring back our begin play node, so just type begin play to apply the search filter. You can then either press the enter key or left click to create the node. When you hover over a node, you will see the move cursor. If you left click, you can grab the node and drag it to another position. You can also do this with multiple nodes selected at once. And you can even use the arrow keys on your keyboard to move nodes around. You can right click and drag to move the visible area of the event graph. Let's have a closer look at the begin play event. This event is fired off when the game begins for this actor. In case the actor was placed in the world, this is triggered once we start the game. But this is also triggered for actors that are spawned dynamically later on. Move your mouse over to the arrow on the begin play node. Hold your left click and drag the line to the right to open the context menu. Now type print string to create a new node that will display whatever text we write into the in-string parameter. To test this out, go back to the third person map. When we press play now, you can see that hello is being printed out once because we have one instance of our BP test actor active in the world. If we add 2 more instances by just dragging them into the game world, you can see that hello is being printed out 3 times, since the begin play will be fired separately on each of these blueprints. Let's delete 2 of these instances again by selecting them and pressing delete on the keyboard. We can do this by selecting them in the game world, but we can also do this in the outliner on the right. As you can see, the print string node is marked as development only. So you might ask what the purpose of logging text is. Well, we can't just log text that we write ourselves, but we can use this for debugging by printing out properties of certain components, for example. We can grab a reference to our sphere onto the event graph and then pull the get world scale node from it. When you hover over the yellow pin, you can see that the return value here is a vector. If you aren't too sure what a vector is, you don't have to worry about it for now. You just need to know that this is not text. So when we connect the pin from our return value to the in-string pin, Unreal Engine will automatically add a node for us to convert the format of this value to text. You can also expand the print string node to show additional options. Sometimes 2 seconds aren't enough, so we can set the duration to something like 5 seconds. We can also change the text color to something that is better recognizable against the blue sky. When we press play now, you can see the scale of our sphere printed out. Printing out values like this is extremely helpful when you don't have a UI implemented yet, or you need to check a value at a certain time to figure out why something isn't working out properly. When you go back to the viewport of the blueprint and select the sphere, you can see the materials on the right side. We can select basic asset 03, for example, to make the ball green. And this again will reflect on all instances of our blueprint in the game world. but let's set this back to basic shape material to make the sphere white again. Now back in our begin play, after printing a string, we can grab a reference to our sphere and pull off the set material node from it. The element index we want to affect is 0, and the material we want in this case is basic asset 03. You can see that the sphere is still white in the viewport and also in the game world. But when we press play now, the begin play is fired off, our text is printed out and the material on the sphere is changed. Changing the material is great for showing you when this event is triggered, but it's not really something useful you would do in a real project, since we can just select the material inside the blueprint. Generally you would use this for things like setting the current health to max health, starting timers and things of that nature. You might assume that the construction script is similar to begin play, but it is actually quite different. Like the tooltip suggests, this function is called whenever a blueprint is placed or modified. Let's cut out our blueprint string and set material by pressing Ctrl X. Then paste them into the construction script by pressing Ctrl V. And connect the nodes by left clicking and then dragging. To better demonstrate when the constructor script is triggered, we now don't want to get the world scale of our sphere, but rather we want to display the location of our blueprint actor. Don't forget to press save and compile and then go to the viewport tab. You can see that the green color is already being applied even though we didn't hit play. Also, when we go to our map, you can see that the instance of our blueprint here also has the color applied. But we cannot see the message in the top left of our screen. Print string from the construction script only appears in the output log at the bottom. We can open up this tray by clicking on this panel and then click on Dock in Layout to keep it open. Now grab the sphere in the world and move it around. You can see that the construction script is called every time our position, or any other property for that matter, changes. You can now close the output log again. So what is this useful for then? From my experience, I barely ever use the construction script. Most things I want to edit can just be set in the default properties of the blueprint or be set on begin play. The construction script is mostly used to create prefabs that make things easier for level designers to create dynamic objects. I remember one of the assets I used for my hunter game I made a long time ago had a tree blueprint that would use the construction script to randomize the properties of the tree whenever you drag it around in the scene. Let's go back to our blueprint and talk about tick. Tick is called on every frame while the game is running. To understand how tick works, you need to know about frame rates. But this is a very deep topic and I can't go into detail in this short video, so I will just tell you what is most important for you to know right now. For consoles, a lot of games target 30 or 60 frames per second. But with the PS5 and Xbox Series X, some games start to support up to 120 FPS. Most games on PC tend to have an unlocked frame rate and will run as fast as your rig allows it. And recently more and more people are buying 120 to 300 Hz displays to enjoy those benefits. Ideally you want your frame rate to be as high as possible, but you should at least aim to have your game run at a stable 60 FPS to ensure it runs smoothly. So what does that entail for a tick event? Depending on the device your game is played on, the tick event will fire off somewhere between 30 and 300 times within a single second. This means that we need to be very careful what kind of computations we do in this event. This is especially true if you plan on spawning tens or hundreds of instances of this blueprint, like you would for gunboats or zombie enemies. So you should only use tick when it is necessary. Just to demonstrate, let me print a string in a random color on tick. You can see that this is being executed in very fast succession. To see what frame rate your game is running at, you can press the menu button on the top left and enable Show FPS. You can see that my game is running at about 60 FPS, which means that the tick event is being fired off 60 times per second as well and prints the text each time. But generally speaking, you will have a higher frame rate once you build your game out into an executable file, because the editor is also doing a lot of other things that are using up resources. Just to demonstrate this, I can force the max FPS to 5 frames per second by using the T max FPS 5 command down here on the console. You can see that the string is now being printed at much slower intervals and the game is running choppy. To set the FPS back to unlocked, you can type in T max FPS 0. If you don't do this, your editor will actually also only operate at 5 FPS and that makes it very hard to work with. So what would you use tick for in a real world scenario? This should mainly be used for incrementing counters, setting rotations, or other things that need to happen every time the game is updated. There are also other ways to handle things like this by using timers, timelines, or subroutines, but it depends on the specific case what approach is better. An example from our VR game are the flying enemies. I wanted to keep these very simple and not give them any complicated AI or pathfinding, so on tick they will always rotate in the direction of the targeted player and move towards him. If they are close enough, they will initialize an attack. Let's implement some very simple and common blueprints as examples to learn more about collision, how blueprints interact with each other, variables, and other things that you will often come across when working with blueprints. We want to use our BP test and turn it into a simple pickup. You can right click and select rename or just hit F2 to rename the blueprint. Let's now delete the print string after the event tick. First we want this blueprint to detect when the third person character touches it and destroy it. To do that we select our sphere and click add to attach a box collision to it. We then want to change the scale of it to 1.5 so it is slightly bigger than the sphere itself. You might still remember the event actor begin overlap node that has been sitting on our blueprint unattended since the start. Since we added the box collision, this node will now fire off whenever another object that has the correct collision channel set up overlaps with this box. We can simply add a print string node here and drag the pin from other actor to inString. Unreal Engine is nice enough to automatically sandwich the getDisplayName node in here for us to show the name of whatever object touches our collision box. You can see that the ground doesn't trigger the print string since it has a different collision setup. But if our player character touches the collision box on the sphere, we see the name displayed. Instead of printing a string, we can now destroy the actor by using the destroy actor node. And as you can see, this works perfectly. But I personally don't like using the actor begin overlap since it is very vague and it can get messy if you have multiple things that can overlap on your blueprint. A better solution is to select the box collision and scroll all the way down in the details panel. We then want to click the plus icon for the onComponentBegin overlap event. This node does a similar thing to actor begin overlap, but it actually gives us much more information about the overlap event itself, and it is also very clear that this is referring to the overlap of the box, so I generally prefer using this. We can now delete the actor begin overlap node and connect destroy actor to our new node instead. A problem that might arise here is that the box collision is now overlapping with the collision of the sphere itself and our actor is destroyed right away. To only allow the third person character to trigger the destroy actor function, we need to add one more node in between. Drag off of other actor and search for cast to BP third person character. Casting is again another deep topic that extends the scope of this video, but in simple terms it will check if the other actor can be converted to a third person character or not. Casting is actually quite computationally heavy and will also create a hard reference, so as you become more experienced you'd often want to use an interface instead. But for your first couple of games you really don't have to worry about it. If the actor can be cast to a third person character, it does continue executing the nodes on the right. If the cast fails, it will continue executing from the cast failed pin. We can add a print string here at the bottom to demonstrate that. If our collision box overlaps with anything that is not a third person character, it will simply print the name. Otherwise it will be destroyed. But a pickup that only destroys itself and doesn't give a benefit to the player is really bad. So let's prepare some functionality on our player which will then be triggered by the pickup blueprint. We first need to find the blueprint for the third person character. Since this blueprint was provided to us from the get-go, it isn't in the blueprints folder we created. We need to navigate to Content, Third Person, Blueprints, and then open up BP Third Person Character. Just looking around in this blueprint, you can tell that there's a lot more going on than in our own pickup blueprint. The event graph has a lot of movement logic, so if we add our own functionality here, things will become a bit unorganized. We can actually create another event graph by clicking on the plus icon over here and call it Interactions. Let's create an event that we want to trigger from our pickup. Right click and search for Add Custom Event and name it Collect Pickup. For now, let's just print a string and then save and compile. Back in the pickup, we now want to drag a line from as_bp third person character pin and call our collect pickup event on the character. This event only exists on blueprints of the BP third person character class, so you cannot call it on any actors that are of a different type. When we collect the pickup, we can see that our player character prints the string to the screen. This doesn't seem like a huge accomplishment, but you've actually just done something really amazing and made two blueprints interact with each other. Understanding how this works sets you up to become able to create many of the game mechanics you see commonly used in all games. We now want to save a number with the amount of pickups the player has collected, so this is the perfect opportunity to talk about variables. Variables are again not something that is unique to Unreal Engine, but a cornerstone of all programming languages and visual scripting tools. You can think of a variable as a container that holds a piece of data and can be referred to by a name. You can click on the plus icon here on the left side to create a new variable and name it. Let's call our variable collected amount. By default, the type of our variable is set to blueprint, which is a data type that can only hold a value of either true or false. But we want our collected amount to be a number we can increase each time we pick up another object. When you open up this menu, however, you see a lot of different types, and that can be quite intimidating for a beginner to understand. But if you just hover over the type, a tooltip will pop up and give you some more information. You can even hold Ctrl+Alt to get a more complete explanation for some of these. You will become more familiar with these types as you try to solve different problems and handle different types of data. But for now we just want to have a simple number, so just select integer. While this variable is selected, you can see more information about it in the details panel on the right. The most important one for us is the default value, but we need to compile the blueprint for it to become visible. You can see that this value starts at 0, which makes sense for our collected amount. But if you had a value like health, for example, you might want it to start at 100. So in that case, you could adjust the default value here. We now want to increase the amount by 1 each time a pickup is collected and print a string with our current amount. You can simply grab the variable and drag it onto the event graph, and you will then be asked to create a getter or a setter. You can actually shortcut this by just holding Ctrl before you let go of your mouse for a getter and Alt for a setter. To set the new amount, we need to get our current amount and add 1 to it. We can drag a line off of the collected amount node and search for add, or just type in the plus symbol. On the plus node, we want to type in 1 as the other value to add, and set the result as our collected amount. We now want to print a string with some text and the amount. To do that, we can drag away from the in_pin string and add an append node. We can then type our text into A and drag our collected amount into B. Let's add a few more instances of our pickup to the scene. When you collect them now, you can see that the amount increases each time. This is a system you could easily reuse for coins or other pickups. There is actually a shorthand you can use for incrementing the collected amount by 1, which is ++, that you can use instead to reduce the amount of nodes needed. Let's give the pickup one additional effect and use that as a chance to talk about functions and parameters. In addition to increasing the collected amount, we want each pickup to make the character move faster. To achieve that, we need to use the character movement component, which is part of the third-person character blueprint. Just drag out a reference to the character movement component and pull out the set max walk speed node from it. This will allow us to set the maximum walk speed by changing this one value. But since we don't just want to set a certain value but increase the value each time, we first need to know what the current value is. To do that, we can get another reference to our character movement component and use the get max walk speed node. We then want to add to the value, so use the add node again. Let's put in a really big value like 200, and let's also print the newly set amount so we can confirm that everything is working correctly. We can just copy and paste our print string and append node from the collected amount, and then again get max walk speed from the character movement component. And let's also change the color of the string. When you play in editor now, you can see that all of this is working perfectly and our character becomes faster and faster as we pick up more pickups. But our blueprints are starting to become somewhat unorganized and hard to understand. I actually made a full video prior with 15 tips on how to keep your blueprints clean and organized, so you can check that out later and dive deeper into that topic. But for now, let's just add a sequence node to prevent our node flow from being as horizontal as it is right now. The sequence node will just call everything that is connected to in order and will allow us to rearrange our nodes to be more vertical. We want to have our logic for the collected amount at the top and the logic for the movement speed at the bottom. To cut the string that connects two nodes, there are multiple ways. I personally like to just double click on the string to create a reroute node and then select it and delete it. But you could also click one side of the line at the connected pin while holding Ctrl and then place it in an open area. This will open up the context menu, but you can cancel out of it by left clicking somewhere else, which will then also delete the line. We then bring our movement logic to the bottom and connect it. If you don't like how unorganized the lines are, you can again double click the line to create a reroute node and align it. This is already looking a lot better, but there are still a few things we can improve. We generally want to make things reusable and organized, so having this collect pickup event that increases the collected amount and updates the character's walk speed just out of the event graph is considered bad practice. If we end up having another actor that also increases our move speed, we would have to copy and paste a lot of the nodes, which isn't good. So we want to turn each of these lines into their own reusable function. An easy way to create a function is to just select the nodes you want to be affected, right click on one of them and select collapse to function. You will then be prompted to set a name for the function. We could also do the same thing for our movement functionality, but I'll show you another way as well. You can click on the plus symbol here next to our functions and again set the name for it. Then select all the nodes you want to put into the function and cut them out by using Ctrl+X. And paste them into the function with Ctrl and Z. Back on the event graph, we can use this function by just selecting it and dragging it here. Inside of the increase move speed function, we still have a hard-coded value of 200 here, which is not great for understandability and reusability. We don't want our character to decide this number, but we want our pickup to decide this, since we could have pickups with different walk speed increase values. To make that possible, we need to select the main node of the function to show the details panel. We then want to add an input parameter here by pressing the plus icon. This should be of type float and be named increase amount. We then need to connect these nodes and save and compile. Back on the event graph, you can now see that increase walk speed is asking for the increase amount value we just added. At this level, we still don't know what value the pickup wants to give us though, so there are two ways to go about this. For the first method, we can create another input parameter on the collect pickup event, which is being called by our pickup. A shortcut for doing this is to actually just drag the line onto the event or function node. Compile, save, and then open up the pickup blueprint. Here you can see that the collect pickup event is now also asking for this increase amount. We can simply put in 20 as a value here, and again it is cleaner to have this as a variable rather than a hard-coded number. So we can just drag off here and promote to variable. And save and compile. And you can see that everything is behaving correctly. Alternatively, we could just call the increase collected and increase move speed functions directly from the pickup. And get rid of the collected pickup event altogether. There isn't really one method here that is superior, and it depends on the specific case which one is preferred, but generally speaking both ways are fine. Now that our pickups are working, we want to be able to spawn them from within another blueprint, instead of having to place them into the world. In some cases you want a designer to go in and place every object individually to create the perfect flow for the game, but otherwise you want to randomize things to make sure not every playthrough is the same. In the case of these pickups, I just want to spawn them randomly in our game area, and this is the perfect opportunity to show you how you can use loops and spawn actors. Let's get rid of all the pickups in our scene. You can hold Shift to select multiple ones and then press Delete. Go into the content drawer and create a new blueprint based on actor and call it BP Pickup Spawner. We want to be able to set an area in which our pickups spawn, and we will use the box collision as our bounding box for that. On the event graph, create a random point and bounding box node. This will give us a random location within the bounds of the box we created, granted that we give it the correct information. Grab a reference to our box and put it on the event graph. The center should be the location of our box in the world. We can get this location by using getWorldLocation node. The half size is a bit confusing, and up until Unreal Engine 4 this pin was actually called box extent. So we just need to get the box extent from our box and plug it in here. As always, we can now just use a print string to check what values we are getting here. First, drag out one instance of the pickup spawner blueprint and place it in the world. When we start the game now, we can see a number for X, Y, and Z, which is the random location within our box that we got. When you stop and start the game again and again, you can see that it is slightly different each time. Let's make the box a bit bigger so it spans across most of our playing field. If you want to move the camera around to get a better view, you can hold right click and move with the WASD keys. With the pickup spawner selected, you can select the box we attached to this blueprint prior. We could also scale up the box inside of the blueprint itself, but since we want to match the size to something in the world, it makes a lot more sense to set it here on the instance directly. You can then just drag on the value for X and Y on the box extent to make it bigger, and match the play area. When you start the game now, you see that the range of values we are getting is a lot wider than it was before, with the small box. Instead of just printing a string, we now want to spawn an instance of our pickup. Right click and search for Spawn Actor from class. For the class to spawn, we want to select our BP pickup we created prior. It also asks us for a spawn transform. A transform is a special structure that is a combination of location, rotation, and scale. The only thing we really care about though in this case is the location, so we can right-click the pin and select Split Struct Pin. We then plug in the random point as the spawn location. The rotation and scale is fine as the default value in this case. The collision handling override is actually very important and shouldn't be overlooked. When Unreal Engine spawns an object, it will check if the location is even available or if the location is blocked by another object. If the location is blocked, your object might end up not being spawned at all, which could lead to a lot of nasty bugs. In most cases, I select Try to adjust location, but always spawn here. If the location is blocked, it will try to move the object slightly and then spawn it again. But even if the location is still blocked, it is guaranteed that the object is spawned. In some cases this can lead for objects to suddenly be flung across the map, but this is often still a better solution than not spawning it at all. When we start the game now, we can see that a single pickup is being spawned. But even if we zoom out before pressing play, once the game starts we take control of our character and it might be hard to see what's going on. We can actually start the game as a simulation without possessing the character. To do that, click on this triple dot icon and select Simulate. You can now stop and start the game as much as you like while adjusting your camera angle and getting a good look at what is going on. Now that we are successfully spawning one pickup, we want to increase this number to something that makes a little more sense. To achieve this, we want to add a for loop in between begin play and the spawn actor node. A for loop will repeat everything that comes after the loop body pin as many times as we tell it to. Once we are done looping, it will then fire off the complete pin. As with most other programming languages, a for loop generally starts at the index of 0, which can be a very confusing concept for a beginner. Let's say we want to spawn 5 pickups. You might think that we should set the last index to 5 to achieve this, but since our index starts at 0, the loop will actually execute 6 times and spawn 6 spheres. We are now left with two options. We can either always specify the last index as a number that is 1 lower than the amount we actually want, or set the first index to start at 1. In this case, I believe the latter makes the most sense, so let's type 1 here. You can see that we are now spawning 5 spheres just like we wanted to. But just typing the 5 in here as it stands is actually considered bad practice, because we need to open up this blueprint each time we want to change this number, and it is also not a variable with an identifiable name. So just like we did for a collected amount on our character before, we now want to add a variable here that is an integer. We can press the plus icon here again, but we can also just drag a line out from the pin here and search for promote to variable, and it will create this variable for us with the correct data type. Another great thing about variables is that you can edit them on a per instance basis if you make them public. Just click this eye icon here. Let's call this variable spawn amount to make it very clear what this does. Don't forget to save and compile. And when we select our instance of the spawner in the map, you can now see that the spawn amount variable is being exposed. Instead of having to open up the blueprint each time, we can now simply change the number here. This is especially powerful if you work together with a designer, since he doesn't have to worry about blueprints and can just change a few values here and there to adjust how a level plays. When you have multiple instances of the same blueprint active in the world, you can also use different values for each one, which is again a really powerful tool. Let's make a simple elevator now to talk about timelines and how to move objects through blueprints. Open up the content drawer and create another blueprint based on actor and call it BP elevator. The first thing we need is a platform we can stand on, and we can do that by adding a cube. To turn the cube into a platform, we want to scale it down on the z-axis only, so make sure that the lock is open and type 0.2 here. We need to have a start and an end position for the movement of the platform. A really great component we can use for that is the scene component. Scene components are great to use when you want to group things or just want to use their position and rotation for something. We want one for the bottom position and one for the top position. When you press the add button, the new component will be attached to the currently selected component, so make sure you don't attach these to the cube, but to the default scene route. If you made a mistake, you can drag the components around and fix it. The bottom position is already set correctly, but we want to move the top position straight upward. We can select it and grab it by the blue arrow on the gizmo. A problem we have now though is that when we select something else, we don't really have any indication of where our scene object is located. A way to work around that is to use a billboard component and attach it to each of the scene components. When you add the billboard component to the top position, however, you see that it is in a strange position and not where we set our top position. While the billboard is selected, we need to go to the details panel and reset the location. Now it moves with our scene component. The billboards are by default only shown when the game is not actively being played. Let's place an instance of our blueprint into the scene to demonstrate that. You can see the billboards while we are editing the scene, but not when playing the game, which is exactly what we want. Go back into the blueprint and feel free to select any color you like for the cube. Now that we set up the base, let's add movement to our elevator. You might think that we want to do this on tick since we need to update the position smoothly many times, but in the case of Unreal Engine we can just use a timeline for this instead, which makes it a lot cleaner and easier to implement. Search for Add Timeline. A timeline will allow us to create keyframes and manipulate values over time. One way to use it is to simply output a value between 0 and 1, which changes over time and can be used as an alpha. Double-click the node and add a track of type float. We now want to right-click and add a keyframe. This keyframe should start at the 0 time and also have the value of 0. We now want to add another keyframe near the end. Since the timeline is 5 seconds by default, let's also set the keyframe to the 5-second mark and give it a value of 1. There are a lot more detailed settings you could do in this window, but this is sufficient for our elevator. So let's rename this track to alpha and then go back to the event graph. You can see that the timeline node now has the float pin called alpha we just created. Now let's see what numbers we are getting out of this whenever update fires, by using a print string. You can see that we get a number that slowly goes from 0 to 1 and then stops. We can use this as a factor to move our platform to the top position. To change the location of the platform, we need to add the node of set world location. For the new location, we now want to get a value between the top position and the bottom position using our alpha. For this we need the lerp vector node. The way this node works is actually very simple. You plug in a location for A and also for B, and depending on what alpha you give it, it will output a value between them. If the alpha is 0, it will simply output the value A. If the alpha is 1, it will output the value B. If it's 0.5 for example, it will output the value in between both, and all the numbers in between also work. Which is why this works perfectly with a timeline. When we start the game now, you can see that the platform moves up slowly with our number and then stops once we reach 1. This is a good first step, but an elevator that only goes up isn't very useful. We now need to make sure that we keep on looping back up and down indefinitely, and for this we need to make use of play from start, reverse from end, and the finish pin. Reverse from end will start moving the timeline again, but this time from 1 to 0 instead. So this is what we are looking for to move downward again. Finished will trigger once our alpha reaches the end point of either 1 or 0. So you might think we can just plug finished into reverse from end, but Unreal Engine won't let us do that. So we need to create a custom event, and let's call it move elevator. We can then plug this into reverse from end and call it from finished. Now we can see the elevator moves up and down, but once we reach the bottom point it bugs out and teleports to the top. We need to add one more thing to make this work properly, and that is the flip-flop node. The flip-flop node will remember the path it took last time and will take a different execution route the next time. This means we will take the A path first and call play from start, and when it's called the next time we will follow the B path and reverse from end, and keep on looping that. We then also want to call this from begin play instead of plugging it into the timeline. This way we get a flow of A, B, and so on. When you press play while the blueprint is open and select the active instance of your elevator, you can actually inspect the execution flow of the nodes. This can be very helpful for debugging. Let's create one more blueprint to finish our simple game and give it an ending. In this actor we will use branches, delays, sounds and also particle effects, which are all things you'll want to use in your own projects. First go back to the content drawer and create another blueprint based on actor. Call this BP goal trigger. Just like we did for the elevator, we want to add a platform here and set the scale on the z-axis to 0.2 to make it flat. This time we also want to make it a bit longer on the y-axis by setting the scale to something around 2. Again, you can select any material you like for the color. Add a box collision as a child of our platform and move it to the far end. Let's put an instance of this blueprint into the world now, next to our elevator. Your rotation might not be correct, so you can use the buttons at the top to go into rotation mode and change the gizmo type. You can then click the blue area and rotate the object by 90 degrees. While an object is selected, you can also change the gizmo mode by pressing W, A or R. Let's go back to simulation mode to see if our elevator and goal trigger line up. You can see that the elevator doesn't reach up high enough, so we want to adjust the top position scene object for this instance. Select the elevator and in here select the top position. You can now drag this up and change it for this instance of the blueprint only. Now things are looking good, so let's work on the logic of our goal trigger. Again, we want to check for overlap with our third person character, so select the collision box and add an event for onComponent begin overlap. And as we did before, we want to cast the other actor to third person character, to only trigger this when our player overlaps this box. When the player overlaps, we want to have two different outcomes, depending on whether or not the player collected more than 5 pickups. To do this, we need to introduce branching logic. We can get the collected amount from our player and then check if it's greater or equal to 5. This node will return either true or false. We can then add a branch node here which will have separate execution flows for true and false. If you are familiar with programming, this is quite similar to an if-else statement. At first, let's just display a message that changes depending on if the statement is true or not. But the alpha that our elevator prints out is now starting to become problematic, since it won't let us see any other messages. Let's delete these nodes. You can see now that if we haven't collected enough pickups, we get the "you died" message. If we collected more than 5 though, we win. Let's go back into the blueprint and add some more functionality. If we die, we want to destroy the player character and play an explosion effect and sound. To spawn a particle effect, we can use spawn emitter at location. There are a lot of pins here, but you don't have to worry about most of them. We want to spawn the particle effect where our box collision is, so we can just get the world location from it and plug it in. As the emitter template, we then want to select P explosion. We have this effect in our project files because we picked enable starter content when creating this project. We then also want to play a sound using the play sound at location node. And again use the location of the box. For the sound we then search for explosion Q. And as the last step, call destroy actor on the third person character. You can see that all of this is working fine, but to be able to play again we need to manually stop and start the game. Let's restart the game automatically after a short delay. We can use the delay node here and set the duration to something like 2 seconds. The delay node is really useful if you just want to offset the timing of the nodes after that a bit, but it can get a bit tricky since you can only use this on the event graph but not inside of functions. After the delay was completed, we can use open level to reload the map. As the level name, we type in the name of the map we want to open. In our case, this is third person map. You can see that after our character explodes and we wait for 2 seconds, the game restarts. Now let's add the logic for the win case. Here we only want to play a jingle. In this case we don't care where the sound is located in 3D space, so we can just use the play sound 2D node and select starter music cue as the sound. When we step into this trigger now, after collecting 5 pickups, the sound is playing and we won, instead of exploding and dying. There is one more problem left though, and that is that we can trigger the goal over and over again and all the sounds start to overlap. We can simply use a do once node here after checking the win condition to allow everything after to only be triggered once. And let's confirm that this works. Congratulations, you just finished your first small game with blueprints and hopefully learned a lot of things about how to use variables, set up simple blueprint interactions, use functions and much more, which you can apply to your own projects from now on. Just by knowing about how to use the very basics of blueprints, you can already recreate mechanics of many classic games. So I definitely encourage you to open up a new project and try to create something new from scratch that is similar to what you just learned, to get some more practice in. Maybe instead of the pickup making your character run faster, they can make him jump higher and then make a short level that runs with that idea. These are all things you should be able to do by slightly changing the nodes that we created together and play around with it a little bit. Definitely show your friends what you have been able to create by just following this simple tutorial and encourage them to get started with Unreal Engine as well. If you need some more ideas on what to make, I have a bunch of other devlogs and tutorials on this channel, so consider subscribing if you enjoyed this video. As you start to add more and more functionality to your game, the blueprints can become quite dirty and unorganized, and preventing that goes over the scope of this video. But I already created an in-depth video about that topic in the past, so make sure to check it out if you want to know more about that. See you in the next video.